Hey, what's going on, guys? KIM-1 here. In this video I'd like to introduce a new feature for my online KIM-1 emulator, and it's a converter program. So most of the software for KIM-1 is distributed in the form of so-called paper tape. And here, well, currently we have two options here. So the first option is to convert the paper tape to this is, I call it DCB dump. DCB most likely stands for declare byte. So the idea is to have the format that can be assembled by this assembler. So just to give you an idea how the format actually sort of looks like. So if I go to the software, and here I already have the bytes for KIM-Venture. So this is what I call the DCB format. So this format can be plugged in, can be directly plugged into the emulator here, and assemble, upload, and run, and that would work. I've been demonstrating that before. But what if we have the paper tape as an input? So here I have the KIM-Venture game in the paper tape format provided by Dominic Van Backe, by the way. So yeah. And I will now convert this to the format specific to this emulator, which means that literally whatever KIM-1 software you have, you may convert this and run on this particular emulator. So let's start by the data for 0 pages, and this is the paper tape format for KIM-1. So it has the number of bytes in hexadecimal that we have in the line. Then the next 4 digits is the address, is the origin where this particular byte starts at, and the last 4 digits is the checksum for all this kind of bytes available within the line. So if I just grab this one and go into my emulator and go into the converter and paste here, so we need to paste the source format, whatever, here on the left. And then we want to say paper tape to DCB dump. And I just click this, and here, copy. So it tells me that the origin is 0000. That's where you want to upload this. And I put it in and assemble, and OK, and upload. And now it's right over in the memory. So far, so good. Now the next one would be this one with the origin 0 hundredths hexadecimal. So going back to the emulator, go into converter and paste it in, and paper tape to DCB dump, and copy and paste, assemble. This one I want to assemble at 0100 hexadecimal. Okay, so go into 0100, nothing there, but once I upload, the bytes are going in there. So far so good. And the very last but not least is this the subroutines at 1780. So I copy this one as well and go into the converter, and here we go, copy, paste, assemble, and the origin is 1780. Okay, and go into 1780 and upload, and we get the bytes. Now the problem is that this original version is not 100% compatible with the emulator, and I have adopted this version so that it doesn't result in smashing the stack. But and I have the version here basically. Yeah, here I have that. So it just uses a hack to reupload, to relocate the delete object routine at 0x 400 hexadecimal. And yeah, this version is slightly bit different. It has this extra line and a couple of function calls like being changed within the source code. So if you want to play the KIM-Venture, you definitely need to make sure to use this version in particular. But what I'm trying to show here, because of the fact that the KIM-Venture is probably one of the biggest games in terms of using literally all the memory locations available for free, and it's quite pretty complicated. It's really complicated. So that's I just wanted to show you that the entire paper tape format gets converted to this. I call it DCB dump, the declare byte dump. Literally just the format that this particular assembler understands, right? So if I now go to 0100 and go, and you see like KIM-Venture is now playing. So you're at stream, what to do, and I'm going north. Okay, go north, you're at house, and so on. I can't pick objects here because of the text matching as I've been mentioning before. But again, like, feel free to use the version that is already adopted. So here I just wanted to give you an idea that the paper tape format gets translated into the format that this assembler understands. We can upload things and play the game, and this should be working in theory with whatever paper tape you might have come up with. All right, so far so good. So here I can actually stop, all right? And I would probably let me just re-upload the initial part, because when I want to be assembling this back to the paper tape, that's another important feature, just to make sure that we reset all the variables, otherwise it's just not going to be matching. So just re-upload this. So I'm going to converter back, and here, okay, copy and paste, assemble, 0000, okay, and upload. Yeah, probably. Okay, guys. Sorry. Let's just start this from scratch. Yeah, I would rather just try to start this from scratch, actually. So, copy and paste, assemble, like this. Okay, upload. Well, this is a little bit. Okay. Oh my god, what have I done? I was trying to. Oh man, I was trying to assemble. What have I done? Shame on me. Okay, guys, I'm sorry. Yeah, just I'm tired. It's too late already. So I need to take the paper tape like this. I was using the hex dump. Oh man. Okay, so here we go, like this. Copy and going back to the emulator. Let's reset it and paste and assemble 0200. Okay, upload. So here we go. So now we have this chunk here working, and now we'll do the opposite. So let's say that no matter that we did input the data like using this format by assembling the code and uploading, let's consider we don't have this at all. Let's consider we just manually typed in the program, or even we could have write an assembly program here, for instance. So I can show you that with the hello world as well that we've been writing before. But just to give an idea, just want to show you that the paper tape that is created by this converter is going to be exactly the same as the original paper tape. So here we have the data in the memory, and now if I go to hex dump, here is the hex dump. So if I just grab everything and copy, and going back to converter and paste it here. So again, like, whatever we want to change goes to the left, and the converted format goes to the right. And now if I push this button, if I click this button, to hex dump goes to paper tape. So here is the hex dump from the KIM's from the emulator's memory. And here we're going, we just created a paper tape. And now, just to make sure that this is encoded properly, so I just copy this one. And here is the original paper tape. And now let's just go and compare them line by line. So the checksum is 0BAA, 0BAA, 07C4, 07C4, and this one, for instance, 0889, 0889. The bytes are also the same. I've been checking that many times. So we have 18 bytes, it's not 18 bytes, it's 18 in hexadecimal. So 18. Here we have 17, and the bytes, and the final number of how many lines we eventually come up with. So now this, what we just assembled, can be loaded into the KIM, or the KIM-1, or whatever KIM you have, via the serial port, and that's pretty much all about it. So you can just like load this into your KIM and enjoy this program. So for instance, well, it's quite clear that obviously we already have the KIM Venture game in the paper tape format. But what if let's say we just created a sort of let's say we've created a sort of a program, and for instance, I will go for this particular version of Hello that I have here. So if I just grab this Hello version, this Hello World version, and I'm going to the emulator, and let's just update things. So here I just paste, and since this is the assembly language, we don't need to convert anything. So this is going to be assembled automatically. We only need to specify where to upload this, and we want to upload this at 200 hexadecimal. So upload 200 hexadecimal, okay. Go in there, 0200 200 hexadecimal. Oh, I forgot to upload. Okay, 0200. Upload, go, we got hello. So let's consider that we've developed a game or a program or whatever here in this emulator, and now we want to test this on the real hardware. So what we can do, we go into hex dump, and here is the hex dump, and now I just want to grab this entire hex dump, so copy. Now I'm going back to the converter and paste here and hex dump to paper tape, and we got a paper tape that in theory should be working on the real KIM. Since I don't have one yet, I can't test this, but I'm almost sure that this should be working. So this exact bytes would be transferred onto into the real KIM, and it's gonna be working just perfectly well. So feel free to test this sort of a thing, guys, and if anything goes wrong, please let me know in the commentaries. So yeah, I'm very serious about maintaining this project because it's really getting interested. So yeah, this is it from my side. Thanks for watching. Until the next time, and take care.